Hello, this is Mr. Huff, and I want to continue talking about summary statistics and looking at variation. Big idea in statistics is the idea of standard deviation, and it's a way to measure variation. So basically, the standard deviation is a number that tells us about the spread of the data values. So the larger your standard deviation is, the wider the spread of the data values. And the smaller it is, the closer the measurements are together. The formula looks a little bit intimidating, but it's not bad. Let's go through what they mean. This letter here is called a sigma. It's lowercase. And it represents the standard deviation for a population. This means that you have considered every measurement in the data set, that all of the possible things you could measure have been measured. It's not a sample, it's everything, okay? So you simply add up the difference between the measured value and the mean. So you take the measured value minus the mean, square that, and then you take all of those values, add them together, divide them by the number in the population, and then that value, you take the square root, and that will be your standard deviation. So to do this, the procedure that Project Lead the Way suggests is that you calculate the mean first. You subtract the mean from each value and then square the difference. And then you sum all of the squares, and then you divide the sum of the squares by the number in the population, and then you take the square root of that result. And then they talk about rounding again, and these you want to go at least one decimal place beyond what the mean and that sort of thing are. So here's an example of them calculating the standard deviation of this data set. So the first thing you have to do is find the mean. And they find the mean at 47.63. And then you subtract the difference from each value and square it. Okay, so you take each number, subtract it from the mean you just calculated, and square that result. So in the first one, you would have 2 minus 47.63 and square that, and you get 2082.67777. And the next one is 5 minus the mean, take the square of that, you get 1817, and you keep doing that on and on and on. Okay. Notice that when you're far from the mean, let me go back one. When you're far from the mean, like 2 and 63, the numbers tend to be a little bit high. And when you're really close to the mean, like here you have 48 versus 47.63, the number is really low. So after you find the squares of the differences, you add all of those up, and you get a really large number, and then you divide that by the number in the population. So in this case we had 11 values, so we took 5024 and divided by 11, we got 456.7769. So that's what we just did there. We've done everything under the square root right here. Then you take the square root of that value and you find a standard deviation of 21.4. This tells us about the variation from across the population, and we'll talk about it in class. This can tell you, if you continue doing measurements, you can use this value to estimate what the values are likely to be as long as it is a normal distribution. We'll talk about histograms later.